This is the spec for radical equations. Radical equations 1. And I view this as very similar to the level 3 linear equations, except in the place of x, you will have a square root of x, or the principal root of x. So a very basic problem that we might see in this module might be 5 times the square root of x plus 14 is equal to 29. And there might be a square root of x on this side, and you'd have to combine terms. And then the hints here, we would subtract 14 from both sides. And you could actually use the code from the level 3 linear equations, just replace the x with the square root of x, and then do one step at the end. So you would say, on that module it says, well, we could just do, well, let me just write it. Actually, let me write it the way we do it over there. So it is 5 times the square root of x plus 14 is equal to 29. And then in that module, we say subtract 14 from both sides. Subtract 14 from both sides, just like the level 3 linear equation module. Do it exactly the same way. So then you get 5 times the square root of x is equal to 15. And then you say divide both sides by 15. So then you by 5, and then you get the square root of x is equal to 3. And then this is the step that would not be in the level 3 linear equations module. You would square both sides. Square both sides, and you would get square root of x squared is equal to 3 squared, or x is equal to 9. And obviously 9 should be one of the solutions. Now, the one thing that makes these problems a little bit tricky is the situation. Let me delete all of this. Is the situation, let me clear this. The situation if this was a negative 1. So if we had the square is equal to negative 1, and you should present this type of problem to the student, and they should realize that there is no solution to this. So the same thing, subtract 14 from both sides, you get 5 times the square root of x is equal to negative 15. Divide both sides by 5, you get the square root of x is equal to negative 3. Now, there's a strong temptation when you see this right over here to square both sides, and you get x is equal to 9. And x equal to 9 would be a valid solution if you were taking the positive or negative square root of x. But we are only taking the principal root of x. And the principal root is the non-negative square root of x. So we could say the next step would be the principal root of a number cannot be negative. So there is no solution. No solution. And in the videos, I'll explain. We'll make some videos for this. Well, why? If you square both sides, you'll get 9. But then if you take the principal root of 9 here, this isn't going to work out. You have to take the negative square root of 9. So in all of these, we should always put no solution as one of the options. No solution. And then put all the other parts. You should actually always put 9 here as one of the solutions, because the student might just go through it very mechanically, square both sides, and say, oh, x is equal to 9, and just choose it. But then they don't realize that they implicitly said that the principal square root of x is equal to negative 3. And if they were to substitute the 9 back in and take the principal root, they would see that it doesn't work out. Now, the other types of problems we want, and just like I said, it's just like level 3 linear equations, except instead of an x, you see a square root of x. So you might see something like this. Let's say we have 5 times the square root of x plus 3 is equal to 6 times the square root of x minus 2. Same process, we go on. And then we see if there is a solution, or if we get to a step that says the square root of x is equal to a negative number, we explain that there is no solution. But there should always be a no solution choice. And even when there is no solution, if you square it and come up with a solution, that should also be one of the incorrect answers. So hopefully that gives a good sense of how to do the radical equations 1 module.